In this video, we're going to express an integral as an infinite series from 0 to x for all values of x. The thing is, we don't know how to integrate this, so we would turn this into a series, and then we would integrate the series. If you look at this, cos of x, it works for all values of x. So the first step is to turn this into a series, and then express this as a series, and then we can divide by t. So the first step is to express this as a series. So let's zoom into this bit here. So zooming in would give us this whole thing here. So the first step is to express cos of t as a series. Well, imagine this as being a t. So you would put this into here. So that would then give you this. So cos of t can be expressed as a series. So now we need to look at 1 minus cos of t. So that would be 1 minus this thing here, which is this thing here. So 1 minus cos of t is this thing here. So now tidy this up. So when n equals 0, you see the first term of this. When n equals 0, the first term will be 1, and then this one here will cancel out with this. Well, when n equals 0, the first term. Well, when n equals 0, put 0 into here. 2 times 0, this would be t to the power of 0, which will be 1. Anything to the power of 0 is 1. Put 0 into here. So this will be minus 1 to the power of 0. Anything to the power of 0 is 1. And then put 0 into here. 2 times 0 would be 0. 0 factorial would be 1. So so the first term will be 1. Everything will the first term will be 1. So that first term will cancel out with this one here. So if you tidy this up, it will then give you this. But then this time you start with 1. Now let me go back one step. So we were currently here. The thing is, the first term of this summation is 1. So we cancel out with this. So now you've got minus, and then you've got minus all the rest. Well, all the rest starts at 1. Well, think about it. From here, that will then take you to here. So now you've got a minus 1 here. So push this minus 1 into here. So this becomes plus 1. So push this into here. That will then give you this thing here plus 1. This thing here plus 1. And then now we've got to divide everything by t. So divide everything by t. So you dividing everything by t, this thing here will get minus by 1. So you dividing everything by t, this whole thing here will then become this. Because you divide by t, then this gets minus by 1. So that's 2n minus 1. And then now let me think. So we don't know how to integrate this, but we can integrate the whole series. So integrating this would be, well, if you have x squared, if you integrate x squared, it would be a third x to the power of 3. So if you integrate this, it would be this thing here will be 1 notch higher than this thing here. So when you integrate it, it will be this thing here is 1 notch higher than this. So it's basically this thing plus 1, which would be this. And then you've got to divide it by this thing here. So you've got to divide it by this thing here, which is 2n. Well, think about it. From here, if you integrate the series, it will give you this thing here. But then we're evaluating it from 0 to x. So we're evaluating it from 0 to x. Hang on, let me think. And then when you put 0 into here. When you put 0 into here, it will be 0 to the power of whatever. 0 to the power of whatever, it will be 0. And then the whole thing will be 0. And then when you put x into here, it will be x to the power of 2n, x to the power of 2n. So remember, when you get to this stage, we normally have to do this. This, you put it into here, and then you take away, and then put this into here. But then the thing is, when you put 0 into here, everything disappears. So you can forget about the 0, just concentrate on the x. So when you put, well, this whole thing here will then take you to here. So we've just now expressed an integral as an infinite series. Okay.